Good afternoon and welcome to METALCON Live. I'm Judy Geller, Director of METALCON, and it's really great to have you with us today. Today should have been the first day we all gathered for our 30th anniversary event in Las Vegas. And even though we can't be together in person right now, we have definitely not abandoned our mission of bringing together and educating buyers, sellers, and designers of metal for construction. Far from it. In fact, you can check out the metalcon.com website to see all the virtual METALCON Live content we're going to be offering every month. We have industry level content as well as technical content, content for designers and architects, and soon you will be seeing information about our new METALCON Business Academy, our MBA, if you will. Our metal focused safety program and a series called Metal Architecture with METALCON Live will also be coming online soon. For now, mark your calendars for the next METALCON Live on November 4th at 1 o'clock Eastern Standard Time for a very important topic called, Can You Afford Not to Have Diversity in Your Workforce? Today's session is brought to you by our METALCON partners, the Metal Construction Association. If you are not a member, you may want to check them out. Members get access to technical reports, research data, and a vast network of peers and experts. Members also enjoy a discount on a METALCON booth. Jeff Irwin, Director of Membership Development, is your contact, and his info can be seen on this slide. We'll put it back up at the end of the session, or you can also go to metalconstruction.org for more information. So 2 quick housekeeping notes, and then I'll turn it over to Charlie. If you run into a technical issue, please message METALCON support in the Zoom chat. Also, if you have questions for Charlie, send those via chat and he'll answer them at the end of the session. And if you happen to have any questions, comments, or suggestions for me, you can email me at judy@metalcon.com. And now, without further ado, I would like to introduce Charlie Smith, the National Recover Manager at McElroy Metal.
Thank you. Let me get my screen share here. All right. Let me see if I can get this show going here. Uh-oh. I'm having a little technical difficulty. Close that. Okay. Now what I do here. Hold on just a second. I'm sorry. Okay, are we good? All right, so this is Charlie Smith. I want to thank y'all for being here. We're going to talk about, 12 ways to recover a slope roof with metal. That's a subject I like talking about quite a bit. And we're not going to waste a lot of time chit-chatting. We're just going to get with it. We're going to talk about why metal. That's a pretty good place to start. We'll talk about the types of panels that you can do for recover. We'll talk about using continuous clips and how they can really help you in recover. We'll talk about low slope metal roofing. We'll talk about transverse panels, which is a way to fix problems on low slope metal roofing. We'll talk about recovering existing metal roof. We'll talk about recovering existing sloped, modified, and single ply. And then we'll talk about shingles at the end. So why metal? Probably the biggest reason is that metal's the longest life expectancy of just about anything else out there. 40 to 60 years. 3 or 4 years ago, Rob Haddock and a couple of guys wrote a very important paper where they did a lot of study on galvalume, and galvalume has got a tremendous lifespan. So that's a primary reason to use metal. There's very little maintenance, the lowest cost of ownership, the lowest life cycle cost, 100% recyclable, energy efficient, and very important when you're talking about recover, especially on a metal building, is that the water is channelized. And channelization is what gives you equal loading across the structure. So, there's a lot of metal roofs have been installed, and some of them are installed great, some of them are not, some of them are performing great, some are not. But let's talk about what causes a metal roof to fail. And these are the areas that when I talk about recover, I try to eliminate that problem from occurring again. So number one, poor installation is probably the number one reason why a metal roof would fail. And so we all have to be better at working with great installers and finding great installers and training great installers. So it's a many pronged situation as far as the installation goes, but a metal roof is definitely dependent on the quality of the installation. I think in-laps as being, in this day and age, in-laps in a metal roof, which would be these right here, is probably the single most preventable source of a leak on a metal roof with all the site forming this capabilities that are out there now. Exposed fasteners that penetrate through a metal roof into a building are certainly an area that can cause leaks if they're not installed properly. So you want to keep these to a minimum. Large penetrations in a metal roof can also be an issue, and the larger they are, the more of an issue they can be. And so a lot of care has to be taken to install these things. And one of the issues with structural standing seams, with most of the panels that are out there in the market, and then say a vast majority that are out there, they're very difficult to fix later if there's a problem. And so they're a double lock standing seam, which makes it very difficult to repair. And then ponding water is the last issue. You just can't have ponding water on a metal roof if you expect it to last a long time. So there are three basic types of structural standing seam panels that are out there in the marketplace, and one of them, the most common is going to be the trapezoidal standing seam. This is a 3-inch tall, 24-inch wide, normally industrial standing seam panel. Most every metal building manufacturer makes these panels. They are great on lower slope applications where there are not a lot of visibility. Got a tall watertight seam, and they're really good on situations where you've got a straight line ridge and a straight line eave. You don't want to install this type of trapezoidal standing seam on a panel on a roof that's got hips or valleys. They're very difficult to make watertight. The closures are not made to fit for those types of conditions. And so steeper slope, hips or valleys, you kind of want to move over into this vertical rib style panel. And I want to say a structural standing seam because a structural standing seam is designed to be the roof on open purlins without any additional waterproofing. I prefer my roof to be waterproofing. You don't want to use I wouldn't use a snap together panel on a recover application, just because I think that, you want a watertight roof that's designed to be watertight. And so a structural standing seam is pretty much what I use every time when I do a recover. And then you have a vertical rib double lock standing seam as well. So these two are by far the most common panels out there in the marketplace, and they've got good wind uplift. They get very good wind uplift. They've got watertight seamless sealant in there, but the chief disadvantage to these types of systems is that once they're installed, they're very, very difficult to repair if there's any kind of an issue. If you want to add a curb later or anything like that, then they're very difficult to alter. About, I don't know, maybe 10 years ago, this type of symmetrical T-shaped panel became starting to come onto the market. And there's probably, I don't know, 8 or 10 manufacturers that make this panel now. And this to me is where the business or the future is. for doing recover or doing even new construction, because what these panels give you is the ability to make a simple, easy repair on a metal roof, which is what you really don't get with these double folded seams. So these symmetrical panels have a lot of advantages, and this is, for me, this is all I do anymore, is I just use symmetrical panels just because they give you a much better, I believe, platform. If you're thinking of a roof to last 40 to 60 years, there's all kind of stuff that could happen. And the idea of making a simple repair is a great idea. So these are some of the advantages. Most symmetrical panels can be made on job site to eliminate the inlaps. They're the most watertight seam design. And I say that because with a typical double lock panel, you're going to have an interruption in the sealant wherever there's a clip located into the seam. You got the clip folded into the seam, and then you're going to have sealant in here. And there may be a interruption in that sealant. But with these style panels, the sealant sits on top of this hem here, and the clip sits inside of there. So the sealant is interrupted in one of these symmetrical panels, which makes it more watertight. One of the great things about, doing recover is that with any system now, but but the idea of continuous clips is are available with symmetrical panels and some other double lock panels as well. But they can really help you increase the wind load capacity. So if you're working on an existing building with 5 foot on center purlins, you want to stay at 5 foot, then you can use continuous clips with a lot of these roof systems to increase the wind uplift capacity. So these systems are very easy to fix. You can, the installations on these systems is very much more flexibility. You got more flexibility with the installation. You can start in the middle, work your way out. You can jump curves and come back and backfill holes. The seamer runs in both directions. You get unlimited movement. They're easy to curve or taper. And then a lot of guys are offering 24-inch panels in this style panel, which makes a lot of sense on a lot of jobs. And then most people will let you take this down to a 1/4 on 12 slope. So eliminate the inlaps, numero uno. There's no reason for an inlap on any metal roof these days with this enormous ability to site form panels, whether it's by a contractor or whether it's by a manufacturer. Most everybody is offering some sort of site form panel now to eliminate the inlaps. Continuous clips. This is a great addition, especially if you're going to do recover on like a metal building where you've got an existing purlin spacing, and the added expense of going inside and adding purlins or putting a big grid system on the outside can be totally mitigated by using continuous clips. In our case, we can almost triple the wind uplift capacity of the roof system by using continuous clips and staying at 5 foot on center. So this is a real big deal for me when I'm looking at doing a recover on a metal building, is using continuous clips to be able to meet that wind uplift pressure and even very high wind uplift zones by using these kind of clips. You can see also that the continuous clips have to be pre-installed with this type of a panel, with a symmetrical panel, and that can be more difficult or easier depending on which way you look at it. Symmetrical panels are available with unseamers as well, and this is a really big deal. So this is an unseamer. What it's doing is a seamer. You can see, and it's pulling this plow, and it's opening the cat back up. And so if you ever have a problem with one of these roofs, then you can run the seamer down there, unseamer, open the cat back up, pop the panel out with a paint scraper, and that's about how hard it is to get the panel out of one of these roofs. And then the seam cap is going to be junk, but the fact that you can pull a panel out of one of these roofs in about 5 minutes is pretty darn nice deal. This is a great example of individual panel replaceability. This was a job that we did down in Port Aransas, Texas, and during this Hurricane Harvey that hit a few years ago. So I'm standing on a roof that we had just completed, and this is a roof that was on this condo that was the original roof, and the only damage that was sustained to this roof was when this roof flew off and hit it. So we went up there and marked about 50 panels on this roof that needed to be replaced because they were damaged from flying debris. And boom, bam, it was done. It took it was a very short situation to get this problem resolved. So this individual panel replaceability is a big deal. Also, another big issue with these systems is the ability to remove and to add a curb at a later date. With a double lock standing seam, it's very difficult to add a curb. But with this type of roof system, you can really pull the roof apart, put the curb in correctly with the under-over application, and then you've got a curb, a factory brand new curb installed correctly instead of with a backwater lamp at the top. Low slope metal roofing, there are billions and billions of square feet of metal roofing that's installed on low slope. And some of the biggest issues that you see with these types of roofs are going to be the inlaps and then the curbs. And so I'm going to throw out a couple of ideas on here on how to kind of think about doing these curb flashings in a different way. So what you see here is this particular roof was at 250 feet from the ridge down to the eave. It had about 700 lap joints in it, and it had big time ponding water behind all these curbs. And so we came up with a different system to solve this problem. I think I got one of my slides out of order here. I'm sorry. And so here's your water backed up behind the curb, which is, this is really not a good thing on a metal roof. This will void a warranty on a metal roof and it'll cause a problem. So you don't want ponding water on a metal roof. But this is this idea here called the transverse panel. And the transverse panel is a way to eliminate all the curb flashing on a roof. So this is that roof that we looked at before, in which you can see these panels are run full length. They're 250 feet from the ridge to the eave. But at these curbs, what we did is we install the roof up to the curb. We install the roof in front of the curb. We install the roof on the other side of the curb. And then that left a hole behind the curb all the way up. And so we frame this thing on both sides and then take these short panels and bridge across this frame section. So what you end up with is sidewall flashing on 3 sides of the curb and then a head wall flashing at the bottom. So you don't even have any curb flashing. There's no water ever gets to the curb. So it's really hard for this curb to leak at this point. And you're just diverting all the water into this panel and that panel like it's going to do anyway. So it's just a different idea, a different way to think about it. And there's a lot of cases, especially on these lower slope roofs, when you're doing recover, this is a way to really solve these problems long term. So I'll get into more of that stuff, but this is basically what it looks like. The eave detail's a little bit different now the way I do it, but it's something to think about. This is a job that we did a few years ago. This is in Illinois for WeatherTech, the floor mat people. But you can see they've got this enormous roof with a giant long run. These are the longest panels I think that we've been involved in. These panels are 410 feet long, but more importantly, they have a ton of skylights in this roof. And so I really don't see any way that you're going to install a metal roof with this many skylights in it with panels of that length that you can't, that you're going to make it watertight on a long-term basis. You can also see here just the continuous clips that were pre-installed, and all the clips were installed on this roof before the panels were installed, which is pretty cool. But so this is where this transverse panel comes in on this job, and it really, it's what made this job work. And on this job, because the panel lengths were so long, we ended up this transverse panels were fixed, and the regular roof panels were floating next to them. But you can see on this slide here, this has ended up being the final job. It's a beautiful job, very well done. And, it's hard for me to see where they're going to have a problem with this roof. And so just saying that, you don't have to put a single ply on all these types of roofs. This is a great application for a metal roof, for a long-term roof. They shouldn't have any problems with it. Another issue where I come up with these transverse panels is where you come into really difficult situations flashing wise. Now, I don't know who thought this was a good idea to put this big AC unit right between these 2 posts, but somebody did, and this is a waterproofing nightmare. I mean, there's no way that this type of a flashing boot is going to make this watertight. And so a good way to fix this is to use these transverse panels, but not only use transverse panels, but introduce maybe a PVC clad metal into your metal roof with some heat welded joints around some of these more difficult penetrations. So now you've got this situation down to the smallest problem area, and something that you can repair really easily later by heat welding this material. So this material can fold into the panel seam here on this side, and then integrate it all the way on this curve here. And so we do this around round penetrations and other things that are more difficult. So just something for you to think about is there's other ways, non-traditional ways to handle curves on these low slope roofs. And this works very well. I've had a lot of success doing this. Recover over metal. So here's a great shot of a new roof going on top of an existing screw down roof that, is both rusting and been leaking, got a jillion exposed fasteners in it. And it's hard to see where this new roof is going to leak. So there's quite a few ways that we can do it. And we're going to talk about some of those right now. The number one thing about doing retrofit, what is this new energy code? This is a real important issue that's come to us. So if somebody wants a new roof on their building, well, the code says is that if you put a new roof on and you do a remove and replace, that you got to bring it up to the current energy code. And on a metal building, that can be 9 or 10 inches of bad insulation, which is not every metal building is going to take 9 or 10 inches of bad insulation because they've already got all kind of stuff hanging from the bottom. I mean, it's just not going to work every time. And so, one of the ways to get out of having to bring the building up to the current energy codes is to do a recover. So this is a big reason to do recover on a metal building. So I use this a lot, and it's something to really think about. So if you want to do there's always the decision: do I do a remove and replace, or do I do a recover? And most people generally want to do a remove and replace, and because they don't really understand recover or haven't really heard about it. So some reasons to do a remove and replace is is the underside appearance, is it unacceptable as it is? I mean, is the insulation just falling out and there's really no way to just remove it? Is the disruption to the occupant going to be a problem if you do a remove and replace or a recover? I mean, if the building's wide open and there's nobody in there, then you can do a remove and replace and you're not disturbing anybody. Weight is probably the single biggest issue that comes up with a recover, especially on a metal building. Everybody, the number one concern is the weight of the recover, and some buildings cannot take any additional weight. I mean, it's just pretty simple. They can't. They got too much stuff hanging from the ceiling already. They got too much collateral load. But the IBC for existing buildings has a very, they've got it in the code, they tell you what the rules are. And the rules are basically that you can add 3 pounds, that you can put a new roof on top of an existing building, over the top of an existing roof, as long as you've got, a number of basic ideas are met. Number one, the connection of the new roof to the existing structures got to meet the current wind uplift. Number two, the existing building has got to be suitable for a retrofit. So somebody needs to look at it to make sure that there's not any, the purlins aren't rotten, and that it's a suitable structure, and that it was built to the code when it was built. And and the third big one is that you can do it as long as the new retrofit does not weigh over 3 pounds per square foot. If it's over 3 pounds per square foot, then you need to have an engineering evaluation done on a building. But that 3 pound number is a good number. So diaphragm is a real big deal. So if I'm looking at an existing building and it's got an R panel on the roof, I'm just going to make the assumption that R panel is holding that building square, and that I can't just go back with a standing seam on top of that thing, because we're liable to have a king size problem. And I know there's been some king size problems from doing that stuff. So if you leave an existing R panel in place, then you're not disturbing or altering the diaphragm. And so that's always a good excuse to do a recover over an R panel. Now, existing standing seam, you may have a better reason to remove and replace on an existing standing seam, because the building should be, it should have the proper bracing in the structure. If the purlins or the eave strut are rotten, obviously, sometimes you can add that stuff bottom, but most of the time the roof's got to come off. Now we have done some jobs where you just cut the panel back. If it's just the eave strut, just cut the panels back before the eave strut and just replace the eave strut and then retrofit everything else. Tie-in height is a real big issue on a lot of these big industrial roofs where they got this gigantic curb up there on the top that, you know, there's no room to go up anymore, because you're going to have to go up if you're going to have a, you know, tie-in height issue around a curb heights. And then, you know, also tie-in height at window walls and stuff like that. We run into that quite often. And then I don't know how many jobs we've looked at doing a recover and then, you know, investigated the roof and it's already been recovered. So you can't put two roofs on, can't put a new roof on top of a second roof. So as far as recover, we're going to go over single ply because that's a very popular thing to do. We're going to go over the with frame and the frameless system. So there's quite a few options on how to do a metal roof over a metal roof. So, or a roof over a metal roof. So we'll start with the single ply. So single ply, there's a lot of people that put single plies on top of metal buildings. I can tell you that I can tell you that a metal building is not designed for a smooth surface roof. It's designed for a metal roof. I mean, that's the original design intent. They designed it that way. The IBC allows for a different amount of deflection on a purlin than it does on a bar joist on a typical smooth surface roof. So a typical smooth surface roof is going to have bar joist and it's going to have a steel deck, and then all that, those bar joists are going to have camber, and the camber is going to, you know, is going to flatten out as the dead load's installed, and you're going to have a nice flat roof up there. Well, a metal building is not done with bar joists. It's done with purlins that are run straight, and then the purlins naturally are going to droop a little bit in between the rafters, and that's, you know, probably everybody on this call knows that. But you put and they're allowed to have more deflection because the IBC people know that a metal roof is going to channelize the water and give you equal loading across the entire structure. But once you put a smooth surface roof on top of a metal building, then you change that. You don't have channelization, so the water is going to be free to flow down midspan of the purlin. Or you might get this giant wind blowing water going across the roof sideways, and where it loads up a bunch of water into one bay. Or in this case, what you can see here is this is like the worst case scenario for doing one of these single ply recovers, where they had a low slope metal roof. This was probably a trapezoidal standing seam roof, maybe 200 feet from the ridge to the eave. They had an internal gutter, and then they had a parapet wall. And so they may have had some roof leaks. They had a gutter leak for sure. And so the solution was to fill the gutter, put scuppers out the wall, and run the water out the scuppers, and which was a really bad idea, because this building is not designed to have water backed up on top of the structure like it's going to result like that. So so we talk about this water channelization. It's if the purlin deflects 2 inches on a 25-foot bay, which is the maximum allowable deflection for a purlin, then with a metal roof on there, you're still going to have equal loading. But if they have that deflection with a smooth roof, then that 2 inches of deflection adds a tremendous amount of water on top of the roof. So where do you see this? Where would this happen? It would happen if you had a damaged purlin, an overloaded purlin, something that caused one purlin to start to deflect, that allowed water to start ponding in it. And this is really what ends up happening. And this typically happens down towards the eave. In the case of this roof that we just looked at with the internal gutter, they did like the worst possible thing. They took, the building is designed for this, and then they did this. And so now we're talking about you have two types of deflection here. You got the deflection of the existing roof panel, which for it's L over 60 is the code, and then you have the L over 180 for the purlin. Well, you put 3 inches of water on top of this roof, which is what you bet you're going to get if you've got a scupper, then you're for sure deflecting this first purlin down below the eave strut. And then once you do that on a 1/4 on 12 slope, now the water's flowing uphill to get off the roof, which can cause a giant problem. I mean, water's not, you know, the idea on a roof is the water's not flowing uphill to get off of it. So this is a big deal here. And so on this case, you go back in time on the Google map and you can see here that there was ponding water all along the eave here on this side of the roof. And what this shows is that the first purlin was deflecting below the eave strut. These were all doing it equally, right? So each one of these bays was doing it. So, while it's bad, it wasn't the deal killer. But what you see is this one here is all by itself. And so what that means is that purlin's deflecting and it's not showing ponding water here. That means that the purlins in the next bay are going up because they're connected. So you have this issue where this one goes down and these go up. And once that happens, that's when you start diverting water out of the adjacent bays into this bay. And that's when you have your big problem. And that's what they had, is exactly what happened was the water from the adjacent bays came into this bay and the roof collapsed. And this happened on a Saturday. Fortunately, I was at a school and nobody got hurt. This happened a couple of years ago in St. Louis, I think. Similar situation where an internal gutter was clogged, was covered over with single ply. So I just say that there's a lot of it get this done. And so, you just need to be aware of it. If that's something you're planning on doing, you need to have a little bit, really think through it and make sure an engineer evaluates the structure to make sure you're not going to get excessive deflection. So really the number one way to recover a metal roof with another metal roof is with a notched purlin, which is commonly known as a roof hugger. Okay. It is the best way, no doubt, hands down, to do it. And there's a number of different reasons for this, but I'm going to tell you the number one reason is because in most cases, it's going to add strength to the underlying purlin. So you're taking a purlin that's 8 inches tall and you're stacking another purlin on top of it, and you're creating a taller purlin, and basically, so you're really increasing the load carry capacity of that purlin. Now, I don't know how many roofs I've been up on where it felt like a trampoline when I walked up there. And then after we did the retrofit, it really stiffened it up. So this type of a notched purlin or roof huggers is by far the best way to do it because you get that enhancement. You do not get enhancement on this thing if you have, if you're doing a standing seam and you got a 1 inch offset between the bottom of your roof panel and the top of the purlin. If that's your existing roof, then you're not going to get the enhancement. You get the enhancement when you put that purlin down, the roof hugger sits flat down on the purlin, okay? But this is the best way. The disadvantage of this is it's going to cost more money. So there's less expensive ways to do it. And the fact is, there's a lot of owners, especially private owners, they want to know how much it's going to cost, and they don't want to spend too much money, especially when the single ply costs half as much. So you want to make sure that, that's why we got a bunch of more ways to do it too, is that this is the best, but it's not the best for every case. Okay. And you don't get continuous insulation with this thing. And also, you only do a roof hugger or a notch purlin on an open purlin job. You don't do it on a solid deck job. If the existing roof is on a solid deck, you do it a different way. Okay. So they have a means of framing out the corners with one of these systems. So this is real important. If the roof panel that you're using, you don't have continuous clips, you want to use individual clips, then you're going to have to frame out the corners. This is basically what you do is you run hat sections up and down that attach through to the existing purlins, and then you can run a grid on top of that of either hat sections or other notch purlins, okay? So you can always grid out a roof using one of these systems as well. Base testing, there's been a lot of base testing that's been done recently on these notch purlins to really talk about and document the load carrying capacity increase. And I can tell you that the base test is a 25-foot base single span, and then you just test in a single span. This is a modified base test, which is a 50-foot bay with a lap. And what this really points out, the test really helped point out was that the failure point of these systems is really at the lap. It's not in the midspan. So you get these giant numbers midspan as far as the increase in load carrying capacity, but the failure is really right here, and you don't get as big a number, but you certainly get quite an increase in the load carrying capacity even at the lap. So if your existing roof is a standing seam, before you do anything, the very first thing that you need to understand is what is the clip offset of the existing roof. You need to know, is this thing sitting flat down on the purlin? Is it got a 3/8 inch floating system where the low floating system where the panel is sitting 3/8 of an inch above the purlin? Or is it a high floating system where it's sitting 1 inch or 1 3/8 inch above the purlin? You need to know that first, because that's going to dictate what method you can use to do the retrofit. You want to do the recover, you need to know what method you're going to do. You want to know what options are available to you. So, and I can tell you, most people want to figure this out at the end. You don't want to figure this out at the end. You want to figure this out first. And then that way you know what your options are. Okay. So I can say that if you're in this 3/8 to 0, you got probably 5 different ways to put a new roof on this thing. And if you've got a 1 inch or better, then you got one way or maybe 2. So you need to get that figured out. So the way that you do it most commonly with an offset is that you use a Model T roof hugger. And I'm not a roof hugger salesman, I'm just telling what the facts are. That the Model T has got a special anti-rotation arm that you fasten to the seam to stabilize the part, and then you use a special fastener that stops drilling either 1 inch or 1 3/8 inch from the purlin, so that you put this fastener through these holes in the bottom, and then it stops drilling exactly the right height away, and then you connect that anti-rotation arm, and you got a super stiff part. So that's the way. That's really the best way for sure to do a existing standing seam with an offset. Clip and purlin system works really well on certain types of jobs. So basically, this is a 2-piece system. There's a number of pieces. Everything else we'll be talking about really is a 2-piece system. So a clip and purlin, this is a 12-gauge angle clip that's attached through the roof into the purlin below. And then you've got like a short Zee purlin. This is a 1 3/4 inch tall Zee purlin that connects them. So you can generally, depending on the wind uplift and the snow load, you can put these things, I would say 4 foot apart would be the best case scenario, probably 2, and then 2 foot apart would be probably your worst. These things, if you want to add a lot of bad insulation, these things are going to be a lot less expensive. These things are just a lot less expensive as far as the parts go. You can have more labor because you got more, because you're working with 2 different parts. But anyway, be a little bit taller. You're going to have less attachment back to the structure. So if you're in a really high wind uplift area, you probably just want to use a notch purlin, and you're not going to get, you're not going to be able to do the corner framing very well with this system. And I tell you where I use this system whenever I see one of these foam jobs, man, this is what I use, because I'm really not interested in having somebody chisel a big giant trench down this thing or chisel all the foam off of this roof, because man, foam is a giant problem when you're trying to roof. So chiseling small squares of foam out is a lot better for sure than chiseling the whole roof off. A hat over Zee, or a hat over Zee Clip, or hat over hat. This is a hat over hat system. These work really well as well. So you put hat sections down that go up and down, and then you connect those with another hat section. They work well. There's you can do that with 2 hats, or you can do it with a little Zee clip that connects here, and then you put a hat section across. Those things give you attachment back to the structure, so they work really well. And they cost quite a bit less money than the other systems. This is called the hat and scat. So in this case, in the hat and scat, you take the hat section and you screw it down to the ribs of the R panel or the roof panel that's there. And then maybe you catch one of the leg of the hat section into a purlin, then you put the roof on and scat out of there before the roof blows off. Okay, because it's like the worst thing you can possibly do. There's a lot of guys that do this. This is like the gypsy, the worst way to do this. And this is actually a roof that blew off that we're replacing with a notch purlin and another roof. But don't do a hat and scat. It's not good. Grid systems. Generally, you do a grid system where you run a purlin up and down you attach that to the framing below, and then you put hatch sections or purlins across. You do a grid system when the roof panel that you're going to use will not meet the wind uplift at the current spacing. So use a grid system to tighten up the attachment spacing. So that's either, get it from 7 feet down to 5 feet, or if 5 foot down to 2 foot, or whatever it is that you need to do. But that's how a grid comes in. These things are gonna bump your weight up normally, but you get a chance to add more insulation with them. You're gonna have a tall finished height and not as much attachment back to the structure. So they've got their advantages and disadvantages. A mini Zee and a Hat. This is a rare opportunity deal, but something that we did on a job that worked perfect for this application. This was about a 600,000 square foot water bottling plant outside of Tyler, Texas. And they needed they had zero tolerance for anything coming into the building. They wanted a new roof, but zero tolerance for anything coming into the building. And so what I figured out is you could drill sideways through the standing seam, and you're not going to get anything into the building. And so we ended up coming up with this system where we did a 1 by 1 by 1 by 8 inch long Zee 16 gauge, punched some holes in it, and then mounted it on the side of this trapezoidal standing seam through the clip, and then put a hatch section across it. And then we did 6 wind uplift tests to prove this thing up, just to make sure we could engineer it. And I can say that this thing worked great for this particular application. And one of the reasons we were able to do it, because you really want a direct connection back to the structure. In this case, we couldn't do it without putting a bunch of trash in the building. But this existing roof was installed on the bar joist, so we didn't. That alleviated a lot of the fear of pulling the existing roof off. So, but anyway, I wouldn't do this in a real high wind uplift area, but I can tell you that on this particular job, it worked great. These guys were able to, this is a 250,000 square foot roof. They framed this whole thing out without a single leak, without any disruption whatsoever to the people inside, and then insulated and put the new roof right on top of this. Very fast installation and very clean without any disruption. Infill with rigid insulation. This is a great thing. If your existing roof is on a solid deck, like on a plywood deck or on a steel deck preferably, and specific, if you got a double lock standing seam up there on a metal deck with ISO, that thing's going to be really hard to take off. And so I always try to recover those that make sense with just infill between the ribs of the existing panel with ISO, put a cover board on if you need it, and then go over ice and water shield, and then put the new roof on, attached through to the deck. And it's very fast, waterproof the whole time, which is really nice. You get great insulation coverage, and it's going to be one of the more expensive ways because of the type of insulation, and you're going to add a little bit more weight because you're going to be using rigid insulation. I can tell you that this was the LSU football practice facility in Baton Rouge, and this was after Hurricane Katrina. So this is actually a liner purlin on this existing building over purlins, and a liner panel over purlins. And so it worked out good. And we're doing a lot of this similar stuff now where we've got some jobs where where they want this crazy amount of insulation. They want to do a remove and replace on a metal building, beef up the structure, add purlins, but they want to go back with this R30 or R38 insulation. And so we're basically putting an upside down U panel on there, and then putting the ISO on top of that, and then attaching through to the roof, to the purlins, I'm sorry. In this case, you can attach, in a normal case, you can attach to the deck if you got a 22 gauge deck. But in this case, and other cases over metal buildings, you want to attach back to the purlins if you're going to use a light gauge U panel. So anyway, great system, really worked great. Tall clip. This is going to be the fastest, easiest, quickest, least expensive way to put a new roof on top of an existing roof. And normally we do this over an R panel because you got to have a clip that is going to sit between the purlins and hold your new panel up above the ribs of the existing panel. And then your new panel has got to be on module with your old panel. So this is a existing R panel, 12-inch on center ribs. And then we're putting a new 24-inch wide panel with tall clips installed with the clips installed between every other rib. So it's very fast, very competitive. This is, you know, if I got a single ply guy coming in, then this is kind of where I try to go, especially if it's an R panel, because you're adding very little weight with this type of system. You know, you're like 1.5 pounds per square foot, and you're giving them a 50, 60-year roof for really not much more money than putting a single ply on. But this existing roof panel has to be on module for this thing to work. And there's a limited amount of insulation thickness that you're going to be able to put on this. This is what we do. We use a 24-inch wide panel over the R panel. We get this special EPS cut, fits between the ribs. You can also do bad insulation if you don't like EPS. EPS is certainly not for every job, but it gives you a nice rigid walking surface when you do that. So it's insulation panel clip, and the clips sit down between the insulation boards. And then this is a continuous clip. So higher wind uplift, here's a continuous clip that's installed attached to the purlins, and then the insulation goes in between the clips, and then the panel snaps down. So this is a very effective way to solve a problem on existing panel, give them a good long-term fix. So that'll do it for existing metal roofs. Now we're going to move into modified single ply stuff, and an internally drained single ply or modified roof is normally totally off limits for metal, and I'd say 95% of those jobs are probably off limits. But this was a good example of one that was not off limits, and it lent itself really well to a metal recover. Metal and single ply together, working together to solve this problem. So basically, in order to do this, you got to bring the metal roof up above the existing roof. And in this case, we installed a grid that was attached through this chip deck into some I-beams, and then the grid the I-beams were 8 foot on center, so that's the grid brought us up 4 inches here, and then we did a 2-inch tall purlin going this way, and then tied all this into a single ply trough. And the big deal is to tie it in, you know, to me, the big deal is to tie it in such a way that a single ply that runs back underneath your metal roof is absolutely no value, because you can't ever change the single ply and be effective at changing it out. So you have to install it in such a manner that you can take the fasteners out of the end of the panel and change the single ply out, because the single ply is going to wear out a long time before that metal roof does. And so you want to have that transition point where you can switch the single ply without really disturbing the metal roof. So anyway, in this case, it was 100% continuous clips. The owner was, you know, it was like a $13,000 ad for continuous clips on this job, and it was a $1 million roof job. So it was very little money in the big scheme of things, and they just loved the idea of the continuous clips because of the snow load and whatnot. And then here was our finished product. And then you can also, you know, this was a job where we had these big deep troughs around this. We created these big deep troughs around these giant penetrations, and then ran the water in a single ply into these troughs. So this is another way to do it. And then when this trough wears out, you just pull these fasteners out, and then the single ply with the PVC clad metal pops out, and then you pop it back in, and they put the fasteners back. So I think it's a great idea, great way to solve the problems. Externally drained, these jobs are pretty simple. I mean, if you get a half on 12 or a quarter on 12 or a 1 on 12 existing modified or single ply, I mean, there's nothing in the world that says you can't put a new roof on top of it, as long as you can have something to attach to. I mean, I've done this I don't do it a lot, but I've done it on quite a few jobs. Generally, these things are going to have some undulation in them, and so you can have to shim underneath some clips to kind of do your best to eliminate any ponding water. But I've done this on quite a few jobs. There's no reason why it wouldn't work, and I've been successful doing it. I did this job about 20 years ago. These panels are 300 feet long, and really it turned out to be a nice job. And there was no reason for anything to happen to this job. Last thing is shingles. We'll go over those here quickly. You want to put a new metal roof on shingles, there's a number of different ways to do it. Something that if you want to put a standing seam on top of shingles, then you need to think about this, because if you put a normal clip sitting on top of a shingle, it's going to sit back out of the roof plane. And so it's real important that it's sitting in the right plane. So there's a couple of different ways to do this. So you can do those recover with no ventilation, or you can do it with above sheathing ventilation. And I've certainly prefer to do it with above sheathing ventilation so that you can get the benefit of a ventilated airspace above the shingles, which is going to greatly reduce the heat transfer coming into your building. Big deal to me. So this is a hat or a runner that's attached to the rafters. You can see that this is that these rafters are attached. I mean, these runners are attached to the hat section. They probably used something. Probably should have used a little bit of something a little bit thicker, because these shingles should not be touching a roof panel, because nothing's going to abrade a roof panel better than an asphalt shingle. So these things should be running be a little bit thicker, so there's nothing touching. But you get an airspace here that you don't get any benefit out of. Now you could feel this with insulation, I guess, but this would not be my way to do it. Continuous clips is another way. I mean, you can use a continuous clip, because a continuous clip is just going to touch the tops of the shingles. In this case, we use the continuous clips because these shingles are installed on top of the Tectum 3, which has that 7/16 OSB on it. And the owner was not comfortable, nor were we comfortable with attaching a new roof to that OSB, since it had been getting a bunch of water on it. And the OSB and the Tectum 3 was attached to purlins at 6 foot on center. So we actually installed these continuous clips and attached them all the way through to the purlins at 6 foot on center, and then snap the two new panels into the clips. This is a grid system over top of shingles, where you got rafters that this part of the grid goes up and down. It's attached to the rafter, and then you've got these runners that go sideways, and now you've got an opportunity to have airflow between the two roofs, which is the guys at Oak Ridge Labs had thought, figured out that a ventilated airspace above shingles, even if it's down to 3/4 of an inch, will reduce the heat transfer into the building by 30 to 50%, or 30 to 45%, depending on the color of the roof that you choose. So this ASV business, I think, is real important if you want to recover shingles. And then this is a clip that is 8 inches long, so it sits on 2 shingles. So it's just a different way to solve the problem using a typical situation. But you got a clip that sits on 2 shingles, so it sits in the right roof plane. And then you've got a 3/4 inch airspace below between the 2 roofs. And then you have to ventilate this thing. You want to make sure that this corrugated at the top is to allow air to pass through and give you something to attach the Z closures to. And then you're going to have some way to vent it at the bottom, let the air in, and you got to have the air out at the top. That's what you see up there, that vent strip. And then last thing I want to say is that these are just 4 boxes, 8 by 8 enclosed boxes. This is in Houston, Texas. I built these. Are we done? Okay. And okay. Well, this is this is not that big a deal. It just, we get some really good results from doing this. Okay. Tell me, what do I need?
Charlie, we just have a couple of questions. I'll read them to you. I'll just tell you what they are. So question number 1, is there a crown in the transverse panels?
Yes. It's either sloped from one side to the other, or there's a crown in the middle to make the water flow to the sides.
Question number 2, how do you handle the expansion and contraction on a 410-foot single run panel?
Well, the panel, once we get over like 200, a little over 200 feet, we start thinking about fixing the panel in the middle. And so either, normally you got to choose your point of fixity. So your point of fixity is going to be normally at the top or the bottom. And so for us, it's if it's an architectural roof where you got a steep slope on a solid deck, then we're going to fix the panel at the top and let it float to the eave. If it's on an open frame or retrofit, we're going to fix the panel at the bottom and have a watertight eave, and it's going to float to the ridge. Now, once you get into a super long panel like that, then you're going to have to fix the panel in the middle and float it on both ends. And that job, it had an eave on both ends. So it really, it was pretty simple. We just let that, we attached an angle to the ends of the panel to kind of tie the ends of the panel together and let them float out in and out of the gutter, and then fixed them in the middle.
That's all the questions that we have.
Well, there you have it.
Well, that's great. Well, thank you, Charlie. That was fantastic. If anybody's interested in your slide presentation, they can reach out to us and we'll send it along to them. And otherwise, we hope that everybody found this to be a valuable discussion. And we look forward to seeing you next time on November 4th for the next METALCON Live. Thank you. Thank you, Charlie.
Thank you, Judy.
Bye, everybody.